All right, so suppose that we're asked to find the branch cut in the function capital log of z plus 3 divided by z minus 3. All right? This is a rational function. So I need to be careful in order to determine the full branch cut structure. It should be more or less obvious that you're going to have a cut along the real axis between -3 and +3. That's because when z is between -3 and +3, all right, what we're going to have is the numerator is positive, the denominator is negative. So clearly we have that just by inspection. But how can we do a more robust treatment? So what I'm going to do is I'm going to say, well, look, a branch cut is going to be where z plus 3 divided by z minus 3 is a negative real number. So I would say all right, where R is a real number that's greater than or equal to 0. And now I could just solve. Right? So I would say all right? And I would think about R greater than or equal to 0. When R is equal to 0, this is going to be -1 times 3, -3. As R goes up through 1, this becomes 3 times 0, which is 0. And then as R grows without bound, this tends closer and closer and closer to 1, so it becomes 3 times 1, which is 3. Notice that there are no other problems with this function. There are no other places where z plus 3 divided by z minus 3 can be a negative real number. So that's the entirety of the branch cut for this function. We can also see that by looking in Mathematica. All right, remember the color plot is one of the easiest ways to see branch cuts immediately. So I've got my function log z plus 3 divided by z minus 3. And I get exactly what we were expecting. Now, notice that it goes all the way across. You might think, oh, it's the whole real axis. But it's not. It's just because I'm only plotting from -2 to 2. If I changed it, then it shows exactly what we have discovered.